Hi, my name's Carl Mannion. I'm the practice director for vulnerability management and remediation services here at Optiv. And today I'll be covering a session on leveraging data science and machine learning to modernize vulnerability management and remediation. To give a quick overview about this presentation, I've created a slide that provides you with the initial introduction here. So what we're going to be covering is how you can use a combination of data science and machine learning to process and analyze data on the known vulnerabilities within your organization and correlate that with threat intelligence feeds so that you can come up with a much more accurate view of your overall risk exposure and also automate many of the processes that you use to follow up on remediation activities. A couple of the key takeaways today that we'll focus on is best practices and techniques for using data science and machine learning, again, to automate vulnerability management and remediation activities as part of your program modernization, and then a list of some tools and platforms that can be used for that purpose. All right, so as far as looking at the problem, why would you need to have machine learning and vulnerability remediation incorporate the use of data science as well? So it really is a problem of volume and complexity. And to complicate matters, vulnerability remediation workflows within many organizations just aren't defined very well. They're chaotic. They often spread across multiple different teams, involve multiple steps. So it's not just one group that has to manage the vulnerabilities or find the vulnerabilities and process them in terms of remediation. It's many different organizations or departments within an organization that are working on these things. So between the sheer volume, which sometimes can range into the millions with some large organizations, but certainly is in the tens of thousands for most organizations, and then the different teams and complexity of remediating vulnerabilities, it has become much more common to look at ways for leveraging machine learning to help with improving your capabilities. There's also what I like to call 6 core struggles of vulnerability management that come into play. So these are some common challenges of vulnerability management and remediation that we see across a lot of different organizations. I've listed them out here. Asset discovery process is missing or isn't kept up to date with vulnerability scanning activities. So this is a situation where the client is using a different asset discovery process than what they use for scanning, perhaps, and they're not in sync with each other. So sometimes you have assets that either aren't detected or are not part of the inventory for being scanned or tested, and therefore they're not even visible within the overall program. So that's one of the big problems that we see. Data is not aggregated from the different solutions is another big problem. So you might have network scanners that are running vulnerability scans, application scanners, cloud and container scanners, and you're getting vulnerability results from many different places. You might also have pen testing tools that are collecting information, and the data is not being aggregated into a common repository or common place. So that's also a common problem. Another thing is just the risk attributes have not been identified and assigned to assets. So things like whether they're externally facing systems that are exposed, or if they connect with other sensitive systems or have critical functionality and sensitive data on them. They have vulnerabilities with known exploitability, things like that. Those types of factors are often not being used, and clients are running their vulnerability management program simply based on CVSS scores, not taking into consideration the other factors that could be used to make more intelligent decisions through tagging and labels, for example. Often there's too much time spent in managing remediation tasks. Again, this falls back to the just general amount of chaos and number of teams that often are involved. So when I say chaos, it's not always clear who's supposed to do what on which systems. Sometimes you have an application that's assigned to an application owner, but it exists on a system that has a different system owner. So if you have a vulnerability, but it's based in the root application or the root system, then it's a question of, well, who's responsible for following up the remediation of that. Obviously, it's a shared responsibility, and many times just getting to agreement on who's going to be doing what can take a lot of time. So some of those types of things can be automated with workflows where you make intelligent decisions based on the information you have available. And I'll talk a bit more about that in a minute. As well as the next step is scanning tools continue to identify previously identified issues. So you may have problems that you know about, you've already looked into them. Either you can't do something about them right now, or you're not concerned about them, or they may be even false positives, and you don't want them to show up in scans in the future because it just kind of wastes time, but the system's not getting updated with that information. So scan templates are not being updated, they're out of date. It's another common problem that we see within client programs. And then classic one here, the status and progress reports are just not being tailored and distributed to key stakeholders for use. So this is basically where you're trying to use the same general reports for everybody, and not all of the stakeholders involved are interested in the same information. So having custom tailored reports is much more useful. And if you're leveraging machine learning and data science, it's much easier to do that as part of your overall program. So these are just some of the core struggles that lead to the need for having ultimately automation, but you get to that by having machine learning and data science integrated into your overall program approach. So what is the solution? As we've been talking, data science and machine learning is critical. It's not really a nice to have anymore. It's a must have for organizations that are trying to manage large scale environments, complex environments. The bigger the organization, the more critical it is to be leveraging some form of machine learning. Smaller organizations can maybe get away with it for a while, but even they run into situations where I've seen small organizations with only 15 or 20 applications with 40, 50,000 vulnerabilities. And so trying to process that many vulnerabilities manually is just not very practical. So looking at ways to improve upon that is definitely critical. So one of the key factors that we focus in on is patching, and why you need machine learning. It has been found that manual processes and manual techniques is one of the biggest delays in getting patches deployed. So the faster you can make decisions on what needs to be patched, what can be patched, and what won't cause problems, the better. So integrating machine learning for making decisions like that clearly helps. And then if we look at risk tolerances and vulnerability remediation workflows, we can turn a lot of manual tasks into workloads that are rule-based, and we can process tickets faster, look at who should be working on those individual taskings, and also tracking the remediation process and patching and testing process much more effectively. So implementing and using machine learning and data science is the solution for the problem of complexity and volume. So with that in mind, what is data science and machine learning? And the terms get bounced around a lot. You do see artificial intelligence often being called out as a capability that organizations want to build into their program. But realistically speaking, in the cybersecurity space, there really aren't any true AI systems out there yet. There are some that are evolving, but most of them that have practical applications today are machine learning solutions. So what is that? It's basically a set of algorithms that machines use to help them more accurately describe and identify the situation. And there's a couple of different methods I'll talk about on the next slide here about how you do that. But essentially, the machine learning piece of the puzzle is a subset of data science. So data science is the collection of the data overall and using different methodologies to include machine learning to improve upon processes. Machine learning is a specific approach where you're leveraging automated algorithms within systems. And the way you do that is you typically incorporate the use of either supervised or unsupervised learning. The main difference here between supervised and unsupervised learning has to do with labeled data sets. So with supervised learning, you have data sets that are labeled. With unsupervised, they're not. And you see with large volumes of data, most often unsupervised learning, clearly because there's often not ways or time to go through and pre-label everything. So most of the systems we run into tend to be unsupervised. However, you can incorporate a mixture of these two things, and it's generally referred to as semi-supervised. The methods I've shown over here are the approaches that tie back to each of these: classification, regression, and clustering. As you can see, I put in some definitions here. So classification is just like what it sounds like, where you're classifying or categorizing data based on the labels that have been applied to it. So a classic example of this is something that's been identified as spam. You see a similar one that comes in, it gets immediately put into your spam folder in your inbox. So that's classification. Common use of machine learning to identify patterns that can be labeled quickly. Regression testing is something where you predict the next value based on other values that you have. So it's a bit more complicated, but has to do with collecting up information and then estimating and forecasting some values. You occasionally see that as well within cybersecurity, but you know, the ones that we see most often are clustering and classification. Clustering is where you take things and you group them together by similarities. So that's when you have things that have not been labeled, but you can at least identify similarities between them. So those are the things we typically use the most when it comes to machine learning. That's a quick overview of you know, what is machine learning. We then take a look at the overall vulnerability management and remediation process from a high level. There's basically 4 steps to it. You find vulnerabilities through various methods, detecting vulnerabilities through scanning or security testing, pen testing, application testing. You then need to prioritize those based on the risk that they pose to the organization. Fix them. You know, there's different ways to fix it, either patching, blocking the capability, turning it off, or otherwise fixing it through other security mechanisms. So you can implement additional mitigating controls or deploy additional software, things like that. That all falls into fixing category or remediation. We sometimes just simply call that. And then monitoring has to do with monitoring the work that you've been you've done up to that point. So if you have a vulnerability that you didn't fix, you track it until you do fix it, or you track the remediation activities and decisions around it. So if you have an exception, you would follow up on that exception later at a later time. Or if you did put in a fix, you would monitor it to see how well it worked. You know, common example here is if you look at like log4j and the initial patches that came out, the monitoring the situation led to additional corrections that had to be made, all tied back to that same general vulnerability or set of vulnerabilities. So it's just kind of ongoing monitoring and reporting related to the vulnerabilities. Where we typically see the most impact and uplift for vulnerability management and remediation when it comes to machine learning is when it comes to the prioritization step. So this is usually where machine learning fits in the best and helps us with accelerating the process. We can use, as I mentioned in the previous slide, a combination of supervised and unsupervised methods to do that. All right, so how do you do it? Here's an example of an actual decision-making logic flow, a real simple one to just show you know, what goes into the thought process when you identify a vulnerability, and then need to make a decision on it. So this type of a workflow, a logical workflow like this, can be used to develop machine learning algorithms that use the same general logic. So here we've got vulnerabilities identified and validated, so you know for sure it's a real vulnerability. Now it's the question of, is it possible to remediate it? Meaning, is there a fix for it? Is there a recommended workaround or whatever? If there's a fix for it, a remediation, then you can move to the next step and take action to apply the fix. If there's not a fix, but there's a way to mitigate it, then you can look at additional mitigation controls, or you can accept the risk if there's no way to mitigate it or remediate it. So this flow is just to kind of demonstrate the logic that can be built into a machine learning algorithm. And it's as simple as starting with something like this. Then, of course, there's a lot of permutations of this basic workflow that can be evolved, but this is kind of the initial steps. Taking that a bit further, here's the another model that shows where things could be automated. So if you were to take results from, say, Qualys, Tenable, or Rapid7, and cross-correlate that information for the assets that were identified with those vulnerabilities, so you run scans, you find the results against a set of assets, you then can cross-correlate that information with the data you have, the attributes for your assets in your CMDB. That can be used to then group vulnerabilities by either by department or prioritized lists. Like you could take, maybe you've got a set of Windows servers that exist within your financial department, finance department. Finance and accounting tends to be a very high area of focus for businesses. So more critical systems, right? So you can group things together by assets that have those vulnerabilities and say, based on that information, I'm going to put a higher risk score on those using risk-based prioritization, using a vulnerability calculator that you build in. And so machine learning can be used to automate things like that fairly easily. Where it gets more difficult is if we go down in the diagram here to group assignments. That takes some intervention and planning, but you could certainly assign specific types of vulnerabilities based on the asset groups that they affect to a particular group that works on fixing those things. When you get down into reviewing it and making decisions on whether or not certain solutions are going to be deployed, a lot of that requires intervention of a human to kind of review the step and then approve it to move on to the next step before it can go into another machine learning algorithm or workflow. So within the overall flow of things, you often have to put steps where humans intervene, and then it goes back into a machine learning type algorithm for the next step. Still significantly improves the speed at which things can be processed. All right, so the general concept of operations that we've seen that work the best is to identify vulnerabilities using scanners and testing methods, as I talked about in the previous slide, aggregate that data together into one common repository or platform, and then use that platform to do risk-based prioritization. Excuse me. So that's where you can leverage machine learning and data science most effectively. Then you can send the prioritized results to a ticketing queue, something like ServiceNow, for example, or a SOAR platform, and then continue automation from there. Often there's some steps involved in that process, though, of having a human review it, as I mentioned. And then you basically work towards tuning and optimizing that system over time. So the intent isn't to start with a perfect model at the beginning. It's to start with a working system, keep it simple at first, and then move towards better and better automation using machine learning and data science over a period of time. The focus areas that we recommend looking at for doing that are listed here. So as I've mentioned, prioritization or triage is a key area where you can leverage a machine learning platform that takes advantage of data science and security analytics, usually based on asset criticality or exposure level and current threat intel information, exploitability of known vulnerabilities. That's all built into the machine learning platform. And then it also takes into consideration the ability to fix those. So are there available patches? Are there vendor advisories? All that type of stuff. That's manual, tedious work that a system that is a machine learning system could greatly expedite and help with, prioritizing things for remediation based on all those criteria. The next item that I call out as a focus area here is to identify remediation options. So if there is the ability to fix them, what are the different options? So matching the right remedies to the prioritized vulnerabilities is another area where machine learning can be incorporated. And then automation, which is not the same as machine learning, although a lot of people kind of cross them into each other. Automation has to do with really more of the orchestration process, and it has to do with identifying the logical steps for remediation. A lot of times this just takes the place of like a playbook or remediation playbook or workflow that can be automated with some sort of a platform, again, with a SOAR platform or a ticketing system or something like that. All right, so if we look at real world solutions and how they're put together, using machine learning to automate vulnerability management and remediation, this picture right here is something that's actually from ServiceNow, and it puts it all together. So when you're looking at handling vulnerabilities in a large environment, you clearly wouldn't want to just manage it by spreadsheets, but we do often see that, spreadsheets and email. So using that sort of approach just doesn't give you a very good picture of the overall situation, and it's very hard to track who has worked on what and what's been done. And so generating results into spreadsheets, sending it around by email doesn't work. What you would want to do is definitely leverage a machine learning platform, as I've discussed in previous slides. And the way you do that is shown here in this diagram, where you take the results from a scanner, put it into a platform like ServiceNow, for example, through an API call, create a vulnerability item ticket within the system, and then prioritize actions based on the assigned owners. Each of the vulnerabilities that are associated with an asset might go to different vulnerability owners, for example. And that's like I was talking about, where you have an application, let's say, that maybe has a vulnerability and an underlying system. Maybe it's a server that has a vulnerability. One total system overall, but two different people that need to handle the process for fixing the specific vulnerabilities. One of the vulnerabilities might be in the code of the application. Another vulnerability might be in the underlying system, the server itself or the operating system. Sometimes the fix for those might be to make modifications to system configurations versus code changes, for example. So they're different people. And as I talked about in one of the previous slides, cross-correlating that information with data from your CMDB for asset information is very important for putting together prioritization of what should be worked on first. So leveraging that information, cross-correlating it, you can prioritize and assign ownership to the right people. If they can't, for some reason, fix something, they can push it to an escalate or an exception process for deferral, and then it can be followed up upon later. It doesn't just get lost. If it's in a spreadsheet, it's not as obvious that something couldn't be fixed right now. Maybe, for example, the application can't be fixed right now because maybe your software developer that could fix that is out for 2 weeks or unavailable for some other reason, has some reason why they can't work on it right now. So you might have to defer it for a period of time, or there might be a reason why it doesn't make sense to do the change in the software. Maybe there's a new version that's already been built and it's in testing right now. has a totally different code base, who knows, right? So those things can be captured and documented so that you have full visibility into what's being worked, and if it's not being worked, why it's not being worked, right? As far as remediation. And then you can follow that all the way through with the specific vulnerability remediation owners with an SLA, put timelines on it, follow up with them, and then close it out within the service level agreement that you've established. So fix this within 2 weeks or fix this within 30 days. And if somebody's past that time, you can follow up with them and see what's going on, and then eventually resolve the ticket. So this really shows the end-to-end process. And the benefit here is if you have somebody who leaves the company, they could log into the system and they could see what's been going on and how this was being tracked. So this is leveraging machine learning within the platform, but this just kind of shows the overall end-to-end workflow. One other thing to keep in mind as far as building out a vulnerability management and remediation program, modernizing your capabilities in general, leveraging machine learning and data science, you don't want to just try to do it all at once. It's a process that you go through, a staged process. So most organizations start out with results that they're generating and dumping to spreadsheets, as I've talked about, and that just has limited visibility and long response times. So you want to get to where you're automating prioritization, as I've talked about again, where machine learning is being incorporated into your overall model, and then work towards improving that, improve remediation with, basically it has to do with making sure you're identifying the right owners to remediate things, the right workflows. That's where you'll run into kind of the next set of challenges, and then look at the information that you're collecting from that for trends and continuously focus on improving that to where you get to where you can use the same process across all different types of scanners, incorporate the use of more advanced risk scores and prioritization, considering all the information available, and improving reporting and dashboards to be more customized to end user needs, and ultimately helping with the overall governance, risk and compliance or risk management approach to vulnerability management. There is a process recommended down here at the bottom to show how you go through that. Establish your objectives initially, assess your readiness. That's something a lot of people skip over, but do you have the right people and the right tools in place? If not, you might need to plan on hiring some people along the way or initially, or buying some additional tools. You might have to buy a platform if you don't already have one. So you have to look at what's out there, choose a platform, and I'll talk about some of the tools to consider. Develop your implementation plan for your specific organization. Design, build, and test your workflows for the automation piece. After you have a solution in place, initiate your change management activities as far as how are you going to handle feedback about what's working, what's not working, and then plan for an initial go live for how you're going to start using this machine-based data science approach to managing vulnerabilities more effectively and in a more automated manner, and then measure your success and adjust over time. So these are just kind of a high-level overview of how you can approach implementing machine learning and data science within your overall program. Some of the platforms that are most commonly seen and used for this, I mentioned one already, vulnerability response for ServiceNow is a module that integrates with ServiceNow and can be used to build out machine learning algorithms within the platform. So that is one way you can start using a tool that will help with automation and using machine learning and data science within your overall program. Kenna Security is another very, very popular platform that has some amazing features built into it as well. Incorporates the use of threat intelligence feeds that are built into the cloud platform automatically. I believe there's 20 or so threat intel feeds and over 100 different exploit feeds that come in from Black Hat feeds as part of the Kenna platform. ServiceNow does not have that by default, but you can build it in, and it's highly recommended, obviously, that you would integrate threat intel feeds into ServiceNow vulnerability response as well. leverage that. As far as what you get with it, it's up to which feeds you subscribe to and connect in. Some are free, some are not free. So you'd have to look at your options there. Vulkan is very similar to Kenna and does a lot of the same things that Kenna can do. Helps with automatic prioritization of vulnerabilities based on exploitability and general information available on the threats that are out there related to those vulnerabilities. It can also be used to leverage asset data to help with prioritization of vulnerabilities. And Brinca, very much the same as Vulkan and Cisco's Kenna security. Splunk is another platform I've seen used for this. It's similar to ServiceNow in that you have to build things out more so than what you get with Kenna Security, Vulkan, or Brinca. Kenna, Vulkan, and Brinca more turnkey, out of the box, have some things already built for prioritization. With ServiceNow and Splunk, you would have to build them yourself. The upside there is that it's more customizable. The downside is that it can take more time to develop. But that is another platform that is commonly used, and you can integrate machine learning and data science capabilities and advanced reporting into Splunk as well. So those are some core platforms that are commonly used for machine learning and data science within VM&R programs. As far as other third-party solutions to consider, there's multiple systems that can be integrated once you have a core platform that you're using to prioritize the results. I mentioned automation has a lot to do with the workflows and automating and orchestrating workflows. So typically systems like Jira, ServiceNow, again, Remedy come into play, but also things like Ansible, Chef, Puppet, Phantom, Automox, those can all be used as well. And the patch management solutions obviously also factor in. They can be integrated in with your machine learning platform. I also listed CrowdStrike here as one example of a platform that can be called upon for automated mitigation actions. You can orchestrate certain actions across relevant groups of assets that have the same vulnerability, for example, and kick off workflows to have them fixed. So there's a lot of other platforms that can do that as well. I just listed that one as one example, but these are some integrations that are common that we see that can be also part of the overall solution. So with that, I don't have anything else. If you have any questions, I'm certainly happy to address them and help answer any questions. Looking forward to hearing from you on the subject, and hope you learned something today from this presentation.